Now I will discuss the difference between the distance and displacement. I have shown, suppose the ball is traveling the zigzag curve from A to B like dotted path. So this complete path, this complete length is the distance, but when I join the A and B, I get the displacement. Suppose I join like this. This is the displacement. So now we are discussing the basic differences between the distance and displacement. First difference I want to tell you, this is a scalar quantity and this is a vector quantity. Like this is the displacement and this is a scalar quantity, this is vector quantity. I hope in junior class some of you must be having some idea of the scalar quantity, vector quantity, but here I will give the rough idea. Scalar quantities are those quantities which require only magnitude for their representation. And vector quantities are those quantities which require magnitude as well as direction for their presentation. Suppose I say I move 10 km. If one statement is this, I move 10 km. Another statement is this, I move 10 km towards Bharatiya Vidya Bhavan. What is the basic difference in these two words? Here I have written the magnitude only. This 10 km is nothing, but this is the magnitude. Here I have mentioned the magnitude as well as direction towards which side I am moving. So this first statement, it represents the distance covered, and the second statement, it conveys this is the displacement, because here magnitude as well as direction both are involved. So I hope the first difference is very much clear to all of you. Again I am repeating, distance is a scalar quantity and displacement is a vector quantity. Now I will discuss the second difference. Displacement, just let me clear it first. Displacement can have only positive values, and displacement can be positive, can be negative, and can be zero. How? Let me explain you. Suppose I say I travel 4 km toward this direction, then 3 km toward this direction. I hope all of you agree. Distance covered is given as 7 km. And if somebody asks you to calculate the displacement, you will say this hypotenuse is the displacement, root 4 square plus 3 square, and you will calculate displacement is 5 km. In this activity, we have explained the distance is positive and displacement is also positive. But one important thing we are getting here, displacement is less than distance. In this situation, they are not equal. But if this body travel 4 km toward this direction, then 3 km toward this direction, in this situation, distance and displacement both are same, and that is 7 km. Because this is the initial point, this is final point, there is no bending, so this will be the straight line, and displacement and distance will be same. If I take another example in which I say this is my starting point, you can say it is origin also. Generally on the graph you put 0 0. Suppose I say particle is traveling up to the coordinate 3 0, then this particle return, come to the original position, and then go another side and reach the point having the coordinate minus 5 0. This is the starting point and this is the end point. Now students, if I ask you what is the distance traveled? You will say total traveled path. This is the 3, suppose I say meter, then 3 meter, then again 3 meter 6, then this is 5, that is 11 meter. I hope it is clear. Again I am telling you. Distance is the total traveled path. Firstly, from this point to this 3 meter, then again 3 meter 6, because 3 plus 3 is 6, then 5 you have to add, total is 11 meter. But if you have to calculate the displacement, again I am telling you, displacement is the shortest distance between initial and final point. So this red line will give you the displacement. And I think all of you can easily measure. This is 0, 0 coordinate. This is minus 5, 0. So what I can say, displacement is 5 meter towards negative x-axis. Or you can say minus 5 meter. So distance is still positive. We have discussed the second. Distance is still positive, but displacement is negative. So I think it is clear. And last we have written displacement is 0. If I say same activity which I told in the last slide, if suppose you start from your home, reach to Vidya Ashram, after school gets over, again reach to home, all of you agree your displacement is 0, but distance is not 0. So I have explained you, displacement can be positive, can be negative, and can be 0, but distance is always positive. One more thing I want to mention here, by observing these 3 activities, here distance is 7 km, displacement is 5 km. So if I ask you which is greater, all of you will say displacement is greater in this situation, because it is, let me erase it. I have to use the lighter. Okay, this is good. This is the 7 km and this is 5 km. So what we can say, distance can be greater than displacement, or displacement can be less than this distance, but not always in this situation. Here we are observing displacement and distance both are equal. Again here what we are observing, distance is more than displacement. So one more conclusion we are getting, and you can write in your copies also, that displacement can be equal to or less than distance, not greater than distance. So this is also one explanation which I want to convey to you. One more difference I want to discuss to you in the distance and displacement, which is very simple. Distance depends on the path, but displacement does not depend on the path. Displacement depends on the initial and final position. Let me explain from the last slide only. Here we are observing, in this situation, this is the distance and this is displacement. So displacement, distance depends on the path. If I change the path, suppose, let me change the pen. Suppose I move toward this side, then toward this side, then toward this side, then this, and then here. Again my path is changing, so distance is changing. But initial point is same, final reaching point is same, so displacement is not changing. It means displacement is path independent and distance is path dependent. I hope I have discussed with you the difference between distance and displacement. Now we will see the difference between distance and displacement with the help of a video animation.
When we move from one place to another, the measure of total length we cover is called the distance. So you have to travel to this town and the best route is straight up north. But because of roadworks along the way, we have to take a detour and the distance covered would be something like this. Now when the roadworks are completed, the distance needed to be covered will be something like this. Distance is measured in meters and denoted as lowercase m. The distance between these two towns is about 20,000 meters, but because of the detour, you had to cover a distance of 50,000 meters. Okay, so nobody likes big numbers unless it's your salary. So we should also know that a kilometer is 1,000 meters. In our example, we can say that instead of 20 kilometers, you traveled 50 kilometers. Is distance a scalar or a vector quantity? Think about it. If you say someone traveled 20 kilometers from this point, we can't really tell where they landed up. Maybe here, maybe there, or maybe they just went around in circles. As it does not specify a direction, it is a scalar quantity. That brings us to displacement. So what is displacement? Distance with direction is displacement. Distance with direction? What do we mean by that? You made 2 separate trips to this town. Was the distance covered in both the cases the same? Have a good look. It wasn't. In each of the 2 cases, the distance was different. The time you took for the detour was greater than the time you could go straight across. But if you call someone to tell them where you are, in both the cases, your location is this town, which is 20 kilometers north of your home. The displacement in both the cases is the same. You traveled 20 kilometers north. North shows the direction, and because direction is specified, displacement becomes a vector quantity. Now let's look at this example where a mother asks her son to quietly stay where he is while she takes a quick nap. So now the child runs back and forth many times and returns to the original spot before the mum wakes up. The mum wakes up and sees the child in the same spot, and as she hasn't observed what happened in the last few minutes, she assumes the child has not moved. The child, being the future expert in physics, has in fact disobeyed her instruction and covered lots of distance. But at the same time, he can argue that he did follow his mum's instruction. Lots of distance covered, but zero displacement. If the distance travelled is a straight line, the displacement will be the same magnitude as the distance, but with the direction provided as well. In most cases in our day-to-day lives, the distance covered is greater than the displacement seen. Running errands and travelling back and forth between places cause the amount of distance to build up, though you may not end up very far from home. If you've really understood the difference between distance and displacement, you should be able to answer the next question. When a passenger travels by taxi, is he charged based on the distance or displacement? Taxis charge passengers based on distance. If you go to the neighboring town and return in the same taxi, the taxi meter shows you the charge for the entire round trip. If you now try to explain to the taxi driver that you have had no resultant change in your location and hence you must pay nothing, it will not impress him much.